Hey guys, so most of you made it through your second class last night, so congratulations. Good job. One thing that I didn't get to talk about, that I know I mentioned in some of the videos that I have out there, but just want to make sure that everyone sees it, isn't about Bruno Mars, but situation. So Bruno Mars sells tickets. You can see the tickets, like he's pretty good. And so different seats have different pricing. So let's say that we had some information that there was a venue that had 20,000 seats. So there were 1,500 seats up close that were about $800 a ticket. 5,000, those are your medium grade tickets, not the nosebleeds. Maybe 300 a ticket. And then you got your nosebleeds or bad corners. So let's say there's 13,500 tickets, and those sell for $125 a piece. So these are your big Bruno Mars fans up here paying $800. People that just have some money to throw around, and these people are probably the real fans, but they don't have a lot of money. Or vice versa. I don't know. So, but there's a lot of tickets sold for $125 and so on. So what is the average price of the ticket? What's the standard deviation for the price of a ticket? How would you do that? Obviously, there's a lot more of the cheap seats, right, that are sold for $125. So would that somehow skew our average? Or would you just take the average of these three numbers? Would that do it? And so in chapter 3, they talk about how to do this algebraically, where you would multiply the number of tickets times the number of tickets, or the cost of the ticket, and there's a way to find an average here. So I'm going to show you how to do that. We have a calculator that we're using, and all right, so to find out what the mean and standard deviation are, we could go to summary stats and grouped and bin data. So if something is set up like we have it, stats, summary stats, instead of columns, like we just had one column, we have group bin data. So the counts for this one, well, would the number of tickets or the price per ticket be the counts? And so it would be number of tickets is your counts, and the bins are saying how much each ticket is. And so that would be the price of the ticket. So if I hit compute, I should get the mean price of a ticket, which would be about $219 is the average ticket price if I sold 20,000 tickets with these prices. And that would bring me to a standard deviation of about 181. So there's some fluctuation, some variability within our price of tickets. Obviously, there is variability. Or let's say that you want to go to a Clemson game. So maybe there's a little bit more variability in the prices of tickets to go to a Clemson Tigers football game. And so let's say that the price per ticket for those upper deck seats, there's $100 to $200 per ticket, and we have 50,000 of those. 200 to 500, there's 20,000, and 500 to 1,000, we have 10,000 of those tickets. I think the stadium holds 85 something thousand, so big venue. Now what would I do? Because what would be the average price per ticket paid within each group? How would I figure that out? And we do it the exact same way. So if I go to stat, summary stats, and then grouped or bin data. So these are broken up into the price of the tickets. Again, the counts is the number of tickets, similar to the last one. The bins would be those ranges of tickets. So that's my second dollar ticket. And it's going to find the midpoint, right, of these values. And that's the number it's going to use to help us calculate the mean and the standard deviation. So when I hit compute, again, it finds the mean price of the ticket is about $275. with a standard deviation of about 200. That means, again, we have some variation, and a good bit of variation between the price of our tickets. So this will help you with some of the problems in Chapter 3 with the grouped bin data. I think it's Section 3, and we didn't get to hit that last night. So hope you're having a great day so far. Well, let me know if you have any questions.